All right, let's dive into this research on student attitudes, identity, and aspirations towards science. I'm really curious to unpack these ideas with you.
Yeah, it's really interesting how we talk about how students feel about science. Like it's this big mystery. But those feelings are really at the core of how they engage with it. Everything from classroom behavior to, even thinking about a future career in science.
Definitely. And this research really digs into how complex those feelings actually are, right? You've got attitudes, motivation, even just plain old interest.
Yeah.
And they all kind of blend together. So how do we even begin to measure something as, well, personal as someone's feelings?
It's tough. And the thing is, researchers use all sorts of different tools and methods to try and capture those feelings.
Okay, so if everyone's using different methods, how big of a problem is that?
Well, there was a study in 2022 by Toma. They looked at 18 different tools that researchers were using to measure attitudes towards science. And get this, only 2 out of those 18 actually met the current standards for getting reliable data.
Wait, only 2? So we're saying most of the tools researchers are using might not even be painting an accurate picture.
It really makes you wonder, are we even asking the right questions?
That's a big deal, right? If we can't even get a good read on those basic feelings about science. But then it gets even more complicated when you start to think about all the other things that influence those feelings.
And it's not just about individual quirks, is it? What if a lot of it goes even deeper, like someone's cultural background?
Oh, okay. Now you've got me really intrigued. What do you mean by that? How does a student's culture play into their attitude about science? So cultural background can really impact how students view science. Can you give me an example of that?
Well, there was a study on Asian Chinese students, and it found something really interesting. These students often reported having less interest in science. They weren't as confident in their abilities, but they were still getting really high scores.
So high achievement, but low interest. That kind of goes against everything we think we know, doesn't it?
It really challenges our assumptions. Like
Yeah.
we tend to think smaller class sizes, more hands-on stuff, giving students more of a voice. We think that all leads to more engagement. And of course, then better performance too, right? But in a lot of Asian Chinese cultures, those things aren't always the norm.
So it's not as simple as saying this one approach to teaching science is always going to be the best. We have to consider the culture too, right?
Exactly. What gets students excited about learning? What motivates them? Those things can be different in different cultures. We can't just assume that what works in one place is going to work everywhere.
Okay, that makes a lot of sense. But so far, we've been talking about measuring attitudes
Mm-hmm.
and how culture plays into that. But there's another layer to this, isn't there? How students see themselves, their own identity, in relation to science.
Absolutely. You're right. It's not just about enjoying science class. It's about whether you see yourself as a science person.
Right. So tell me more about that. How does that identity piece fit in? It's like you said before, if a student doesn't see themselves as a science person, it's going to be hard to keep them engaged long term.
And it's not always obvious, right? Like there was this research project, the Aspires project, and they found that even students who really enjoyed doing science activities, even kids who aced their science tests, they still didn't necessarily picture themselves with a career in science.
Interesting. So even if they like science, even if they're good at it, that's not always enough to make them think, this is my thing.
It goes back to those ideas about identity. Who are the people we typically picture when we think of a science person? What does a scientist look like? What are they interested in? Those stereotypes really have an impact.
It makes sense, right? If you don't see yourself reflected in those images, you start to wonder if you belong.
Exactly. And we have to acknowledge that certain groups, because of their background, their culture, maybe even their gender, they've been historically excluded from those images of who does science.
Okay, so how do we change that? How do we broaden those perceptions and help more students feel like they have a place in science?
Well, one concept that comes up is science capital. And it really builds on that idea of identity and belonging.
Science capital. Okay, I've never heard that term before. Tell me more. What is that?
You can almost think of it like, we talk about social capital, right? Well, science capital is kind of like that, but specifically related to science. It includes things like your family's background in science, how much you're exposed to science outside of school, even just having those casual conversations about science at home.
So it's like building up this whole knowledge base about science, but also a comfort level with it, a sense of familiarity.
And all those things contribute to a student's sense of identity, right? It helps them feel like they can actually do science, not just learn about it.
And feeling like you can do something is so powerful. It gives you the confidence to try new things, to take risks, even if you might fail sometimes. Those are all such important parts of science and really just learning in general.
And you know what's interesting? The research actually found that one of the biggest predictors of whether a student felt like they could have a future in STEM, it was whether they had regular conversations about science with their family, even more so than some of those formal science education experiences.
Wow, so those everyday interactions, just talking about science at home, that can have a huge impact.
Absolutely. It shows how important it is to create those opportunities for informal learning, to show kids that science isn't just something you do in a classroom or a lab.
It's about fostering that curiosity, that desire to learn more. It makes me think about, sometimes we get so caught up in teaching the facts, the formulas, the right answers, that we forget about the wonder, the joy of discovery.
Absolutely. And there's so many ways to tap into that, right? Like we were talking before about integrating art with science. That's a perfect example.
Right, finding creative ways to make science relevant, to make it exciting and engaging. It's not just about memorizing information, it's about really understanding how science works and why it matters.
And I think at the end of the day, that's what we want for all students, right? To see themselves as capable of doing science, of contributing to those fields, and to see science as something that's relevant to their lives, something that can help them make sense of the world.
It's about opening doors, showing students all the possibilities that are out there. And who knows, maybe by nurturing that love for science, that sense of wonder, will inspire the next generation of innovators and problem solvers.
Absolutely. Because the world needs more of those, that's for sure.
Could agree more. Well, on that note, I think this has been a fantastic deep dive. Really got me thinking in new ways about how we can support students in their science journeys.
Me too. Thanks for having me.